Let's look at composition of functions from a different perspective. So we just looked at them coming from the equation. You may also be asked to find a composition of functions from a table or from a graph. Here's the thing. It's the same thing as the equation. Think about when you first started learning about graphing functions. You started with an equation, you built a table of values, you took those table of values and put them on a graph. So we're just looking at it from a different perspective here. So here's our table of values. We're only given some select values when x is -2, 0, 1, and 4. We know the values of f of x and of g of x. If the x value is something other than those, we don't have enough information to determine the value. We're only limited to what's here in the table. We're not looking to build a function out of these. We are simply trying to use the information that's given. We're not trying to find an equation, just use the information that's given. So for the first example, f of g of -2. So we want to look at our table. This is our x value. X is -2. So here's x is -2. G of x is equal to 1. So we're going to replace it with its value. G of -2 is equal to 1. So that replaces that there. And then we look at our table. Now the x value is 1. We want the f value. So in this case, the answer is 0. Let's reset things a little bit. Still using the same table, just looking at a different composition. This time we're looking at g of f of 0. Remember, that's not my favorite notation, because when it's written like that, it looks like we're just supposed to do the composition and then multiply everything by 0. So the answer would be 0, but that's not really what it is. It's the exact same thing as writing it this way. So I go ahead and do that to remove any confusion. Let's start with our x value of 0. This time we plug it into f first. So the value of that is 4. F of 0 is 4. So our x value is now 4. This time we want g. G of 4 is -5. So this answer, g of f of 0 is equal to -5. Let's do a couple more just to make sure. F of g of 1, again, this is our x value, so start there. G came first this time, so now it's f of -2, because g of 1 is equal to -2. Then f of -2 from our table, when x is -2, f is equal to 8. So f of g of 1 is 8. Last one, g of f of 4. F of 4 is -4. But when we look at our table, we don't have an x value of -4. We do not have an x value of -4. So it's not that it doesn't exist. It probably does exist. We just don't have enough information to answer that composition solely from this table that we've been given. So we don't have enough information to determine g of f of 4. Similar idea here. Let's look at a graph. Well, we actually have two graphs. We have the graph of one function f of x, another function g of x. Again, this is just like what we were doing with the table, because remember, the points from a table produce the graph. We're just looking at it from that different perspective again. So let's look at the first one, g of f of -5. So again, this is our x value to start with. So we find our x value of -5. We're plugging that into f. F is the blue graph. So we look on the blue graph where x is -5. The y value is -2. So now we have g of -2 because f of -5 is -2. So now we go to the x value. Now our x is -2. G is the purple graph. So when x is -2, the purple graph is equal to 1. So that is the value of g of f of negative 5. F of g of 2, so again, starting with an x value of 2, this time we're starting with g, so its value is negative 3, so that's f of negative 3 now, because g of 2 is negative 3. So now we go to negative 3. Its y value from the f function this time is 6. So f of g of 2 is equal to 6. Last one, g of f of negative 3. Well, we were just there. We just did f of negative 3. F of negative 3 is 6. So now we go to 6, and we want the g value of 6, and that is 1. So g of f of negative 3 is equal to 1. Interesting to note, g of f of negative 5 and g of f of negative 3 have the same value. That has to do with just the properties of plugging the f function into the g function here, and they're both parabolas, so we know that sometimes we have some repeated y values with parabolas. But nothing that you really need to notice there. I just wanted to point that out, that it is possible that even though they are different compositions, g of f of negative 5, g of f of negative 3, it is possible to have the same answer. We could have had the same answer for an f of g. Switching that order, we could have ended up with the same answer for one of them. It just depends.